So again, we are quizzing tomorrow. Not a ton of things on that quiz. There's just a few. The only thing that you would really want to look over tonight to make sure you're good at is inequalities. But other than that, a lot of these questions are asked in everything we do. So we're just going to start off today by doing a few different examples, making sure we understand what's going on. More than anything, it's like, how do I find that? If you know how you find it, then you're going to be great. Okay, so number one, it says find the vertical asymptotes, horizontal or oblique asymptotes, and x-intercepts. Let's start with x-intercepts. If I'm looking for x-intercepts on this graph here, Sam K, how do I find x-intercepts? X equals 3 and x is equal to negative 2. She said she's taking the numerator and setting it equal to 0. And so it's both of those things. The negative 3 doesn't do anything. She would cancel out holes if we had that first, but we didn't have any holes. Good. So x-intercepts, they live in the numerator. We set it equal to 0. We solve. Great. Done with the first part. That was our x-intercepts. Next thing we're going to do is vertical asymptotes. Lydia, where am I going to find vertical asymptotes on this graph? 0, 2, and negative 3. Where are you looking to find vertical asymptotes? The bottom. We take the denominator. If it's not a hole, then it can be a vertical asymptote. So she took each thing, set it equal to 0, and we solved. We get 0, 2, and negative 3. Everybody, show me with your fingers, where's the horizontal or oblique asymptote going to be? Horizontal or oblique asymptote is at an ugly, yeah, you can still show me. Don't be scared. Negative 3 halves would be the correct answer. What's true about my degrees here? They're equal. That's a degree of 3 on top, a degree of 3 on bottom. So then we're looking at leading coefficients. If we were to multiply that out, that's what I'd have left. So I have a horizontal asymptote at y equals negative 3 halves. Leading coefficients. Questions on the first one? Second one, we're just doing long division. This is how we would find an oblique asymptote. Let's just do it real quick. X squared times what gets me x cubed? X. We throw an x on top, then we multiply down. X times x squared is x cubed. X times 3x is 3x squared. We are putting them together. What do I need to remember when I put them together? Change the signs. That cancels. This gets me negative x squared. I can bring down this minus 3. Then we do it again. X squared times what gets me negative x squared? Negative 1. And then we multiply. Negative 3x. We're putting it together. When we put it together, we got to change the signs. That cancels. 3x minus 3. That is a remainder because this degree is bigger than this one. So my answer is x minus 1. And if you want to get fancy, plus 3x minus 3, all divided by x squared plus 3x. That is my remainder over my divisor. That would be my oblique asymptote. Most of the time, we really don't care about the remainder, but we could. Questions? Let's keep it going. Keep the Bellward party rocking here. Here is a graph of a rational with your neighbor. Try and write the equation that would get me that graph. Try to write me the equation that would get me that graph. Take a minute or two here and figure that out with your neighbor. Go. Here we go. We are trying to write the equation of this function, so give it your favorite name. I'm going to call it r of x, but you can call it whatever you would like. R of x because it's a rational. Evan, what's something you had to include in your equation here?
The vertical asymptote.
So what'd you do and where to go?
X plus 5 and x minus 4.
Good. In the denominator, correct?
Yeah.
X plus 5 and x minus 4, that goes in the denominator because they need to be vertical asymptotes. Lovely. Max, what else?
The hole.
There's a hole? Good. What did we do?
X minus 1 in both the denominator.
Good. X minus 1 in both the numerator and the denominator because I had a hole there at x minus 1. I'm in agreement with that. Aaron H., what else did you include? X-intercepts, good. Where did we have them and where do they go? Okay, good. So x plus 2 and an x minus 5 squared in the numerator. Why squared there at x minus 5? Good. It touches my x-axis there. It has a multiplicity of 2. because we're going down to that line and just touching it. Good. So we got vertical asymptotes, we got holes, we've got X-intercepts. That's kind of what we need to work through. Then we're going to do horizontal asymptotes. Looks like I have a horizontal asymptote on this graph at 3. What needs to be true in order for me to have a horizontal asymptote at 3? Kara? Good. We need the degrees to be the same. Okay? The degrees have to be the same in order for there to be a horizontal asymptote anywhere other than 0. And so why did you say here, it's not plus 5 squared. The minus 4 needs to be squared. Yeah, we're good. Minus 4 squared. My fault. I was looking at the wrong one too. X minus 4 squared. Why did you say, Kara, that one is the one that needs to be squared? Good. I am approaching infinity on this side, and then on the other side of the asymptote, I'm also approaching infinity. Both of them are going up, and so because of that, we know that that vertical asymptote is squared. And so to get the horizontal asymptote at 3, we said the degrees need to be the same. They are now, and then so in order to get it at 3, we throw a leading coefficient of 3 in front, and we got everything we want. Questions there? Lots of different things. If you don't believe me, here's a graph of it. Okay, we got that same thing. 3, we got the x minus 1 on top and bottom, x plus 2 on top, x minus 4 squared on bottom. That's what's getting me that right there. And then the x minus 5 squared, that's getting me the touch, and so on. We see everything we need to see there. Good stuff. One last thing here. The key to tomorrow is understanding how do I find these different things. Okay, if you can figure out how to find these things, you will do very well tomorrow. Okay, so with your neighbor, talk through where are you looking in the rational function to find those first 4 things. Talk with each other and go. Let's do it. So we're finding each thing. If you could find each one of these things, you should be good to go. Eli, how do you find the roots? Good. X-intercepts. He's thinking the numerator set numerator equal to 0. And obviously here, there's going to be some different things that are going to affect that. For example, the holes down below it. So yes, we set the numerator equal to 0. That's great. Before we even probably do that, we would find the holes, and we're good with that. Jack, how do I find a hole? Yeah, if factor in numerator, I should have abbreviated that, and denominator are same. And obviously, we know that. We're just writing it down. This is not the proper answer here, but numerator and denominator have the same factor. If when you plug in a number, you get 0 over 0, that's when I know I have a hole. Sophia, how do I find y-intercepts? Plug in 0 for x. That one's always the one that kind of creeps up on us. We know it, but it just looks weird. Plug in 0 for x. And then vertical asymptotes. Abby, how do I find vertical asymptotes? Yep, obviously, again, after we find the holes, then we can set the denominator equal to 0 and solve. That's going to find us vertical asymptotes. Good on the first 4. Let's do the next 4. Same idea. Go back and forth with your neighbor. Try to describe these 4 things and how you find them. Go. Trying to slow down. Horizontal asymptotes. Kendall, when do we find horizontal asymptotes?
You look at the degree on the top and the bottom. If the degree on the bottom is larger than it's automatically 0.
Okay, so degree, and whoa, you're so fast. Degree, if the numerator is less than the denominator, then
0.
Y equals 0. Good. So it's bigger on bottom, it's Y equals 0. Good, keep going.
If the degrees are the same, then you look at the leading coefficient.
If numerator is equal to denominator, then Y equals the leading coefficients. I'm using a whole lot of abbreviation to keep up, but good. We're good with that one. That's the only 2 times we can get horizontal asymptotes. Herman, what about oblique asymptotes? If numerator is greater than denominator by 1, then we have an oblique asymptote. It's a slanted line. We do long division. Can we do synthetic division? Yeah, if our degree on bottom is 1, then yes. Can't always do it, but if we can, do synthetic. If not, do long division. We're good at both of them at this point anyways. Kate, how do we decide when the function crosses my horizontal asymptote?
Don't you like plug in the number for the horizontal asymptote if it has some equation?
You're thinking of the whole.
Oh.
So yes, that is how I find the whole value. You're not wrong though. The simplified version, we take that x value, we plug it in. That would tell me the y value. If I want to just know when they cross, Aaron, see, when do I figure out that? Or how do I figure out that?
You set the horizontal asymptote equal to the function.
Yep. Set the horizontal or the oblique asymptote just equal to my rational. Yeah, it just says horizontal. You're good. Just set it equal to the rational and then solve. You're not wrong though. We've got to do that as well. Good. We've got that. And then the last question is domain. What is the domain? What is going to be our domain of rationals? Let's try to simplify that. What is the domain going to be of my rationals? Good job. Good answer. All real numbers. But x is not equal to what, Max? Vertical asymptotes and the holes. These things are points of discontinuity. Okay, remember I was talking about continuous graphs? Continuous graphs are when you don't pick up your pencil. So if you pick up your pencil, it's not going to be part of my domain for this one. And it's going to be at vertical asymptotes, we pick up our pencil, and at holes. And both of them are points of discontinuity. And then the last one is just the statement. To solve inequalities, use a sign chart. Make sure you can do that. What numbers are going to go on my sign chart when I make it? Vertical asymptotes or X-intercepts. And then do the cool little sign chart. Plus, minus. Real cool. Everybody good? Good stuff. One of two options today. Okay. The rest of the class period today, we are going to review. The first option